Hi, today's video is about integration by substitution method, and we're going to solve three problems here. The first one, the integral of dx over 2x minus 5 raised to 4. To solve this by substitution method, we first let u to be 2x minus 5, no? Without the exponent. No? So, if we get the derivative of this one, du over dx, the derivative of 2x minus 5 with respect to x is 2, no? Because derivative of 5 is 0, negative 5 is 0. So, du over dx is equal to 2. So, therefore, dx is equal to du over 2. After getting these two values here, the 2x minus 5 and dx in terms of u, we substitute the equivalent values of 2x minus 5 and dx back to the integral. So this one, du 2x minus 5 and dx is du over 2. So dx is du over 2, so du over 2, that is the dx. So 2x minus 5 is u, that is raised to 4, so we copy the exponent. So the integral of that will be 1/2 of u raised to negative 4. No? We transfer this in the numerator, du. No? So getting the integral of this one, we put this 1/2 outside the integral sign. So 1/2, the integral of u to negative 4 is simply we add 1 to the exponent. So u raised to negative 4 plus 1 is negative 3. So this exponent here will also be our denominator plus the constant c. So negative 3 and 1 over negative 3 over times 1/2 is negative 1/6. So 2x minus 5 raised to 3 plus c. You can also put this in the numerator, 2x minus 5 raised to negative 3. The same will be correct. No? So for problem number 2, we have here the integral of dy over the quantity 2y minus 5 raised to 7 over 2. Similarly, we let u, this 2y minus 1, will be u. No? So we differentiate du over dy is equal to the differential of 2y minus 1. So the derivative of that is simply 2. No? The derivative of negative 1 is 0. So du over dy is 2. So dy is equal to du over 2. No? This is du. So this 2y minus 1 and du, no, over 2, we substitute back to the integral. No? So dy will be du over 2. No? So u raised to negative 7 over 2. So the integral of that one, no, we put this outside the integral side, so 1/2. So we add 1 again to negative 7 over 2 plus 1 or 2 over 2. And this whole exponent here will also be our denominator. So having said that, 1/2 times 2y minus 1 raised to negative 5 over 2, no? Negative 7 over 2 plus 2 over this, negative 5 over 2. And the same exponent will be used as our denominator plus c. So we simplify this. It becomes, you cancel out 2. We cancel out 2. This one becomes 1/5, no? Negative 1/5, no? So this one is wrong. No? Put this one. This one is 1 pip. No, this one is 1 pip. So, times 1 over 2, 1 minus 1, raised to 5 over 2, no? Plus C. This one cancels out. So, for number 3, we integrate z dz over the square root of 4z squared plus a squared. So, we put this in the numerator. So, the integral of 4z squared plus a squared, this one becomes negative 1 half z dz. Similarly, just the previous problems, we let you to be 4z squared plus a squared. So du, get the differential of du with respect to z is equal to 2 times 4, 8z, no? So this one is 0. So dz is equal to du over 8z. So we make use again of the substitution method. So the integral of u raised to negative 1 half, no? Z du over 8z, no? We substitute, no, du over 8z to be the value of dz. So we have here 1/8 times quantity. We add 1 to the exponent of negative 1 half. So u raised to u raised to 1 minus 1 half. So the same exponent will be used as our denominator, 1 minus 1 half plus c. No? After which, this becomes 1 half. So 1/8 4z squared plus a squared raised to 1 half. We cancel out 2 and 8, no? So 8 will become 1/4. 4z squared plus a squared raised to 1 half plus c. So that's easy, no? So that's how we are going to solve the integration by substitution method. So thank you for watching, and as I've said in the previous exercises, please subscribe to my YouTube channel and click that notification bell. Thank you, and see you next time.